By now, I assume that you've already read this, so I'm just going to point out the important parts for our process. The fact that there's a base value of 500 for renting the space, and that every more person we invite is $25 more. So that's going to give us a really good idea about how much money LGJ is spending throughout this process. The important thing to keep in mind is that there are 5 guests of honor, and they're not going to pay for their meals. So if we were to invite just 5 people, we wouldn't turn any profit. There'd be no one to pay for it. If we were to invite 6 people, it'd be the 5 guests of honor and that one guest who's paying for everything. If we were to invite 10 people, then it'd be the 5 guests of honor and 5 people who are paying for everything. Keep that in mind as we go throughout it. Now, this project's going to be worth half of a test grade. For instance, your tests are all worth 100 points. This one's going to be 50. You're going to be graded on the rubric that's on Google Classroom already. The same rubric is going to be on Jupyter. You can submit this assignment as many times as you'd like at no penalty. And the highest grade will be your final grade on it. Okay? Now, let's take a look at some data points. You're going to fill in the table using the information that was in that introduction. You're going to round the cost per paying to the nearest cent, which means 2 decimal points. All right? Watch out for rounding. It gets everyone. Now, the people attending include the guests of honor. You're going to use these numbers and figure out everything off of it. Well, the number of paying attendees, that's always just going to be 5 less. The guests of honor aren't paying, and there are 5 of them. The total cost to LGJ with renting the space and the meals. Well, we know that renting the space is 500, and the meals are 25 each person, and there are, in this column, 25 people. Here, there are 50. Here, there are 75. So for this, you could just do the 500 plus 25 by the meals times this number. Now, the amount of cost each paying attendee contributes might sound a bit confusing, but all that is saying is if we were to divide the total cost among every paying attendee, how much would they pay? So here, there are going to be 25 people invited, so 20 of them are paying, because remember, those 5 people aren't. So whatever this total cost is, you're going to divide by the 20, which is the one up here too, to get your amount of cost for each attendee. You're going to base B, C, and D off of the table you just made. So what's happening to the cost per individual ticket? That's up here, the amount of cost for each attendee, as more and more people are invited. Why is it happening? You're going to notice a trend happening here. So it's your job to describe the trend as best you can. So is the change in the individual ticket changing at the same amount? For instance, is it the same change in individual ticket price from inviting 25 people to 50? Is it the same as changing from 50 people to 75? So basically, what's the change between these two? And is that the same change as here? Think back to rate of change from Algebra 1. Then, on a sheet of paper, or you can use Desmos, you're going to make a graph with the x value starting at 0 and ending at 200, and the y value starting at 0 ending at 100. You're going to plot the points from the table, where the points are people attending, comma, cost per paying attendee. That might sound confusing. All it means is if 10 people attend, the cost per person is going to be $125. And the cost should be 10, comma, 125. And you're going to get these numbers from this table. So people attending, you already have that information. And then this is just going to be that y value you're going to use. Now, let's talk about part 2, writing an equation for our function. Explain how you found the cost per ticket in the previous part. What steps did you take? Part A does not require any kind of equation. You're just saying how you found the cost per ticket. What did you end up doing? B is relying on A. So write an expression to represent the total cost of the event if X number of people were invited. And remember that includes the 500 for renting the space, and then it also includes the 25 per plate. But then we need to write an expression to represent the number of people who are going to pay for their tickets if X number of people were invited. Remember, there are those 5 people, the guests of honor, who are not paying for their ticket. And I give you a hint, this expression is going to be a lot simpler than many of you may think. Then, using the two expressions you just made, you're going to make a rational equation to represent the relationship between the plots you pointed. The points you plotted. And all that's going to be is stuff you've actually already done. We have the total cost divided by the number of people who pay for their tickets. Lastly, you're going to plot that function on the same graph you plotted your points onto. You can use Desmos to get an idea of the graph and then transfer it over onto your sheet of paper, or you can do the whole thing on Desmos. If you're right, that graph is going to go straight through all 6 of those points. If it doesn't go through those 6 points, recheck the function. Now we're going to interpret the scenario in part 3. So using the graph to explain, and this is very, very important, the graph to explain, why is it better to invite more people rather than less? What's happening as we invite more and more people? Now, why can't we just invite 5 people, specifically the 5 guests of honor? Using the graph, explain what's happening here. Where is the vertical asymptote on this graph? Why does it make sense there would be a vertical asymptote there, according to the equation? So take a look at the equation that you wrote and that you plotted, and say why there's a vertical asymptote there. What's the lowest the ticket can go, and why can't it go below that level? The graph is really going to help you out with that, folks. So take a look at it. Now, part 4, explanations. The space can hold a maximum of 200 people. Write a reasonable domain for this function. Explain why you chose this as your domain. And down at the bottom, you can see this little 2 here. That's a footnote. At the bottom of the page, remember, domain is all the possible x values. So you can write domains a bunch of different ways. I will attach a web page to explain how to do it. So you're just saying in one way, shape, or form what a reasonable number of people would be for this space. So based on the domain you chose, what would be the range? Explain how you found this as your range. And here, the range, I got this little footnote of 3 to remind you, remember, the range is all the possible y values. Last but not least, the function extends into the negative portions of the x and y axis. If you graph it out, you'll see it. Why doesn't it make sense to consider the negative portions of either axis here? Think about what the axes represent in real time, and that's going to help you make your decision. I hope me walking through this helped. If it didn't, you're more than welcome to see me during office hours.